Okay, this is 14b. I just want to show you here. You see that this is just the octahedron, right? And this is the tetrahedron on the face, just like we showed you in the last video. But I've just divided each vector in two, connected that division, and we come up with the two-frequency octahedron and the two-frequency tetrahedron. And then also you start seeing the nature of the matrix of the combination of octahedrons, tetrahedrons, octahedron, tetrahedron. That, and that we could just keep doing this and dividing that into higher and higher frequencies, and the matrix just becomes more higher and higher resolution, or higher frequency. So that's one way that you can visualize how self-development of the increasing frequency of the matrix. And then within the matrix, all the forms are present in some scale at some frequency. I know it's a little bit hard to grasp, but the matrix handles all the forms. Okay. Now I just want to show you that this is what we had there, but this is at one frequency, right? We have one tetrahedron and one octahedron. Okay, now I wanted to explain that idea of the implosion of the tetrastar. Okay, now we know, we can imagine that putting tetrahedrons on all of these faces, right, we come up with the tetrastar. All right, there it is. Okay, now if we take each one of these tetrahedrons and push it through to the other side, it would be like this. Okay, that we've taken the point and we've gone boom, and we've pushed it right into the octahedron. Okay, and I showed you this before in another video. But now if we this gets a little bit crazy, but if we do this to every face of this octahedron, if we implode every tetrahedron on every face, we come up with this construction. Okay, I know that this is just self-developing. It's all the same length pieces of dowel, right? And it develops these geometries by itself, right? It's just, all you do is implode it. All you do is push the tetrahedrons through, and they come out right in the middle of the opposite face. If you push this one through, here's the point of it. Okay, so now some very interesting things happen with this. It's going to be difficult for you to see, I know, but within this structure, and that just in the intersections of these vectors creates locations, and you have lots of choices of what locations to connect, but you can connect locations and you come up with forms inside this construction. Right here in the black, we have the vector equilibrium, which we talked about in the last video, that transformation model, and that happens at 1/4 the dimension of here. So that's, it's an exact 1/4 of the so this actually becomes a 4-frequency octahedron, produces the 1 frequency vector equilibrium in the middle, right? And then also you can see that by putting half octahedrons on the open faces of the vector equilibrium, we come up with, I don't know if you can see it in here in red, but there's an octahedron right here, 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 and that's a 2-frequency octahedron, okay? It's sitting inside a 4-frequency, inside a 4-frequency octahedron. I mean, and that's amazing that happens. Now, here's another possibility of that. This is another model, and all we did is connect different points, right? And in doing so, we ended up with this several different things, constructions here, but in the very middle in orange, there's an octahedron, and that's a 1-frequency octahedron inside a tetrastar, right? And an octet star, I'm sorry. There's this octet star, the octahedron right in the middle, so that the other cell of the matrix is formed here, and just by connecting different intersections from that implosion of the octahedron, of the tetrastar into the octahedron. So, you know, that's pretty amazing stuff. Now, also, there is a tetrastar that's completely rational to this matrix right here. It's here, here, and here, and the tetrahedron, the purple tetrahedron in the middle. So this rationalizes the organic and the inorganic within the same matrix, which is you know, the math is all perfectly rational. In this case, this tetrastar would be 3-frequency, and I'm sorry, is 6-frequency, and the octahedron becomes 15-frequency. I know I'm just saying these, you know, I'm just saying that because I know that it's true, and so the math is just incredible, and that's all done just with the Pythagorean theorem. So here in this model, I have tetrahedrons coming off the face of the tetrastar that start coming down and turn, you know, into the double helix coming out of this construction, you know. So I know that's a lot. We covered a lot right there, but so I'm going to rest with that for a minute.